Hello, this is Mr. Stansbury. I'm going to take you through the 7A assignment, work through all the problems that we were assigned. And again, it's all distance formula, so we're going to use this distance formula here, which again is basically just the difference of the x's squared plus the difference of the y squared, and you square root that, and that gives you your distance between any 2 points. So for A, distance is going to be the square root of, if we're using this formula exactly the way it is, we would take 4. That's the x2, so we do 4 minus the x1, which is 3, squared, and then we're going to add y2, which is 2, and we're going to subtract the y1, which is 1, and square that, and then off we go. So now we just simplify, and again, it's really important to make sure that you simplify in the parentheses first before you square them. So 4 minus 3 is 1, so that's 1 squared. 2 minus 1 is also 1 squared. So the distance is going to be 1 squared is 1, 1 squared is 1. So the distance is going to be the square root of 2 for those 2 points. All right? And you can just leave it in root form is just fine. If that's not satisfying enough, you can always take your calculator out and square root it. All right? B, we've got same thing, distance equals square root of, we'll do 5 minus negative 1, because it's negative 1, squared, plus, and then the y's are 2 minus 2 squared. Alright, so distance equals 5 minus negative 1, those turn into positive, so that's 5 plus 1, so that's 6 squared. And then 2 minus 2 is 0 squared. So the distance on this is simply 6 squared. And if you square root a square, you just get that base number. So the distance in this case will just be 6. You could have square root of 36, but that's a perfect square. So whenever you get a perfect square answer, you always want to, if you got the square root of a perfect square, you always want to take the square root of that perfect square to get your actual whole number answer there. All right? Okay, let's move on to the next one, which is number 2. So to use the distance formula to classify the triangle as either equilateral, isosceles, or scalene. So basically we have to figure out what the distances are between all 3 of these. So honestly, I really kind of like to set up A, B, and C so we can actually see where it's at. So if we were to basically, let's see, 5, go 5, negative 3, we'll put A down here, we'll call it. B is at 1 and 8. Okay, so I'm going to just put B up here. And honestly, it doesn't really matter where you put these points. It's just a visual. 5, negative 3 is A. B is 1, 8. And then C is negative 6 and 1. So we'll put that one over here. We'll do C is negative 6 and 1. And what we're going to try to do is find each of these lengths here. Right? So we'll do these all in different colors to hopefully make this a little bit easier to understand. Oops, pretend that that's a nice straight line. Okay, and oops. We got that there. So let's say if we're let's find the red one first. So that's going to be the distance between C and B. So on that one, it's just going to be distance equals square root. And again, it doesn't matter which one you subtract from which. So we'll do negative 6 minus 1 squared plus 1 minus 8. Squared. So negative 6 and negative 1 is negative 7. So we'll square that negative 7. And then we're going to add 1 minus 8 is also negative 7 squared. So we get that. Negative 7 squared gives us 49. And that's the exact same one there. So that's also 49. So we get that the distance is 49, and 49 is 98. And you can just leave it like that. You could simplify the radical if you want. honestly, for what we're trying to do here, if you just leave it as distance as the square root of 98, that works just fine. So I'm just going to leave it like that. Let's see. Let's do B to A here next. So we will do that one there, and the distance is going to equal, let's go say 1 minus 5, that's a 1 there, squared plus 8 minus negative 3 squared. Okay, so we've got those, and let's simplify this. So the distance is going to equal 1 minus 5 is negative 4 squared. And then we got 8 minus negative 3, which is basically 8 plus 3, so that's 11 squared. So our distance is going to be 16 plus 121. So our distance on this one is the square root of 16, let's see, 121, 31, 137. So that's pretty good distance there. Okay, and then let's do the last one here, the purple one. All right, so that's going to be distance equals, we'll go negative 6. It's this one here, so negative 6 minus 5 squared, and then plus 1 minus negative 3 squared. Okay, so that's going to be negative 11 squared. And then 1 minus negative 3 is 1 plus 3, so that's plus 4 squared. So the distance here is going to be 121 plus 16, which is exactly what we had here. So the distance is square root of 137. So now we've got the 3 lengths here. So this is the square root of 137. This one up here was the square root of 98. And then this green side here is the square root of 137. So is it equilateral, isosceles, or scalene? We've got two sides the same and one's not, so that would make this one isosceles. So we've got, therefore, the triangle, ooh, that is a terrible triangle. Triangle is isosceles. All right? Okay, let's take a look at B. All right, so we've got these 3 points here, and I'm going to, and again, it really doesn't matter if they're represented right as if they were graphed on here, so I'm just going to do this. We're going to do A is at 1, 0. Again, I just like to look at it. It just makes it easier for me. So there's A, and then let's put B down here at, oops, let's put that there so I can write the point next to it, which is 3, 1. And then we'll do C over here, which is 7 and 3. All right, so we'll do the same thing. We'll just connect those all with different colors so we know which side we're doing when. All right, and so we've got those 3 there. So let's start with this AB here. So let's do this. Distance is going to equal square root of 3 minus 1 squared plus 1 minus 0 squared. So the distance on this thing here, 3 minus 1 is 2, so that's 2 squared. 1 minus 0 is 0, plus 1 squared. Since this have a negative, I don't need to worry about the parentheses. So D is going to equal square root of 4 plus 1, so the distance on that is the square root of 5. So this is root 5. Let's go AC here. So the distance on that is going to be square root of 1 minus 7 squared plus 0 minus 3 squared. So that's going to be the square root of 6 squared plus, let's see, 0 minus 3 is negative 3 squared. So the distance is going to be 36 plus 9. So that is square root of 45, right? Okay, square root of 45. So we already know it can't be equilateral because they're not all the same. Let's check out and see what this last side is, and we'll figure out what it is. That didn't make sense. We'll figure out what kind of triangle it is. That's what I'm trying to say. All right, distance from, on the purple one here, from B to C is going to be square root of 3 minus 7 squared plus 1 minus 3 squared. So distance equals 3 minus 7 is negative 4 squared, and then 1 minus 3 is negative 2 squared. So our distance is square root of 16 plus 4. So the distance on that one is the square root of 20. So this is root 20. So since they're all different, that means, therefore, since they're all different, the triangle, I am having a hard time drawing triangles. Triangle is scalene because all the sides are different. Okay? All right. On to the next problem. Use a distance formula to show that the following triangles are right-angled, and in each case state what the right angle is. So again, I'm just going to use the same process that we did before. Just draw the 3 points out here. So let's start with let's just do A up here. A is negative 2, negative 1. B is negative 1, negative 1. And then C here is going to be negative 2, negative, oh, not negative 3, but negative 2, positive 3. Okay, so let's draw our lines here. Ooh, struggling. There we go. And there we go. So let's do A to B here first. So the distance is going to be negative 2 minus negative 1. Make sure with that negative, that double negative, you get both of those in there. That changes the problem. And then it's going to be plus negative 1, oops, minus negative 1 squared. That's a 1, not a parentheses. Okay, so we get distance over here is going to be negative 2 plus 1. So that's just going to be negative 1 squared. And then negative 1 plus 1 is 0 squared. So this distance here, negative 1 squared is simply 1, and then the square root of 1 is just 1. Okay, let's find this one out here. Okay, so distance is going to equal square root of negative 2 minus negative 2 squared plus the difference of the y's, which is negative 1 minus 3. Right, so distance equals, let's see, that's negative 2 plus 2, so that's 0 squared. And then negative 1 and negative 3 is negative 4 squared. So the distance there is going to be, let's see, the square root of, that's 0 plus 16. So the distance is the square root of 16, which is just 4. All right, let's find this BC side here. So distance is going to be square root of, let's go, negative 1 minus negative 2 squared plus negative 1 minus 3 squared. So the distance on here is going to be, let's see, negative 1 plus 2 is 1 squared plus negative 1 and negative 3 is negative 4 squared. So the distance is going to be 1 plus 16. So the distance on this one is the square root of, oops, not 16, but 16 plus 1 is 17. So that's the square root of 17. Now, You know what's really actually going to make it easier is if we, instead of writing that as 4, let's keep that as root 16, and instead of writing that as 1, let's keep that as the square root of 1. And if you notice, that makes it a little bit easier to figure out a squared plus b squared equals c squared. So then that would make this the c squared, which is the hypotenuse, which would be across from the right angle. So that means that we now know that angle A has to be the right angle. So therefore, angle A is the right angle. Okay? Okay, let's take a look at B. It's going to be the same process, just doing the distance formula, and away we go. All right, so B, let's do the same thing. We've got, let's call A at -2, 2. We'll make B here at 4, 2. And then we'll make C over here at 4, -6. All right, just want to double check, make sure I got all my numbers right. And then let's start, let's make our lines so we know which one we're doing when in different colors. You don't obviously have to do this on your assignment. It's just a little bit easier on here to figure out which piece we did when. All right, so let's start with this one here, the AB. So distance is going to equal square root of 4 minus -2 squared, and then 2 minus 2 squared here. All right, so that's 4 plus 2 gives us 6 squared, and then that's gonna 2 minus 2 gives us 0 squared. So our distance here is going to be the square root of 36. Now let's just leave it as the square root of 36. That might end up helping us out at the end instead of simplifying that. So let's leave it as root 36. Let's find this AC here, which is going to be, let's see, we've got -2 minus 4 squared plus 2 minus -6 squared. All right, so let's see, that's going to be -6 squared, and then that's 2 minus -6, which is 2 plus 6, which gives us 8 squared. All right, so that's going to be -6 squared is 36, 8 squared is 64. So this distance here happens to be square root of 100. Right, so we'll just leave that as square root of 100. It could be 10, that's going to be 6. Let's see what this side here is. Let's see, let's use purple for that one. So the distance here is going to be the square root of, let's see, we got 4 minus 4 squared plus 2 minus -6 squared. So that turns into a positive. So we get 4 minus 4 gives us 0. And then 2 plus 6 gives us 8. So we get that our distance is the square root of, 8 squared is 64. So let's just leave it as the square root of 64 here. So then we can look at this and say, oh look, 36 squared plus square root of 36 squared plus the square root of 64 squared equals the square root of 100 squared. So the big one here is definitely going to be our hypotenuse. So that would then make this angle B is going to be our right angle, which of course we didn't draw it to scale, so it doesn't look like it, but it is. So therefore, angle B is the right angle. Okay? All right, well, the last one to take a look at is number 4. All right, so find B given that this stuff here. So now this is a little different because now you're getting a variable in as one of your points, but it does give you the distance. So let's just keep using our distance formula. So for A, we're going to do, let's see, distance equals square root, but actually let's back up here. We actually know what the distance is. The distance is 5, so let's do this. 5 equals square root of, let's do 4 minus b squared plus 10 minus 7, that's a 0, 10 minus 7 squared. Okay, so 5 equals 4 minus b squared. Can't really do much with that, but we can do 10 minus 7 is 3 squared. So we got 5 equals the square root of 4 minus b squared plus 9. Okay, now really the big hang up here is that we have this root here. So if we actually just square both sides here, then we get rid of that root. So we'll get 5 squared is 25. And then over here we've got 4 minus b squared, the square root of all that. So really it's just 4 minus b squared plus 9. Okay, so now let's start moving stuff away so we can get b by itself. So let's subtract 9 from both sides. We get 16 equals 4 minus b squared. We want to get rid of that square, so to undo a square, we square root, right? And then, so now that gives us that square root of 16 is 4, but again, since we're taking the square root of it, it's plus or minus 4 equals 4 minus b. So we subtract 4 from both sides, and we get negative b equals negative 4 plus or minus 4. Now, we don't want negative b, we want to know what positive b is, so we've got to switch all the signs. So we'll do b equals, so that turns into positive 4. We're still adding and subtracting, so if you turn addition into subtraction and subtraction into addition, it's still the same thing, so it's still 4 plus or minus 4. So b has to equal 4 plus 4 is 8, or 4 minus 4 is 0. So b could actually be at 2 different points. It could either be at 8, 7, or it could be at 0, 7. So either one of those answers should work. Okay, so that was A. Let's take a look at B. We're going to basically do the same thing. So we've got the distance is the square root of 20, and that's going to equal, and we use our distance formula, so let's do 3 minus negative 1 squared plus b minus 2 squared. All right, so a nice first step on this is let's get rid of our roots from both sides. So let's just simply square both sides, and we get that 20 is, let's see, let's do 2 steps at once. So we got 3 plus 1 is 4 squared, and then we got b minus 2 squared. All right, so let's simplify this one. 20 equals 16 plus b minus 2 squared, so subtract 16 from both sides, and we get 4 is b minus 2 squared. So again, to get rid of that square root, to get rid of the square, we square root both sides. Square root of 4 is plus or minus 2 equals b minus 2. So now we add 2 to both sides, and we get that b is going to be 2 plus or minus 2. Right? So 2 plus 2 is 4, and 2 minus 2 is 0. So b can equal either one of those. All right? Okay, that's all there is for the 7A assignment. If you have any other questions at all on this, any clarification, please ask in class. All right, thanks.